Hi there everyone. Glad you're joining us today for using M1 systems for access control. My name is Amy Strickland. I'm with our tech support and marketing departments here at ELK. Joining me today is Brad Weeks, who is the manager of our tech support department.
Good afternoon, everyone.
And again, we're going to be talking today about our M1 controls, which include our M1 Gold and our M1 Easy 8, and how those systems can be used for access control. We'll give you a few different examples of how you might use that. We're mostly going to focus on the hardware that's involved and also the programming and everything that you would need to know to actually set it up. So hopefully by the end of this session you'll be very comfortable with how you would use M1 in an access control application. So as I said, a lot of what we're going to be going over today applies to both our M1 Gold and our Easy 8 control. I'm going to focus in a little bit more on the M1 Gold as it is, our higher end system and more commonly used than the Easy 8. So we are going to focus a little bit more on that particular piece of hardware, but just keep in mind that just about everything that we'll be talking about today would also apply to an Easy 8 if you happen to be using one of those. So just going over Gold features, if you're not familiar with the M1, it is a security and automation control platform, 16 zones on board, up to 208 expandable, and it can have wireless up to 144 zones. We also have expansion capability with outputs, and we'll actually be going into a little bit of that hardware as we go through, but you can have up to 205 outputs on the system, which could be relays, voltage outputs, or a combination of the two. The system has different arming levels. You can have it armed to away mode, vacation mode, stay instant, night, and night instant. And the difference between those is based on how you set up your zone definitions and that sort of thing, so that you can have interior zones not be active when you're at stay mode, that sort of thing. Vacation mode is good if you want to do some automation stuff, so that's why we include that. But as far as arming level, it's basically the same as away. The M1 Gold has voice announcements so that it can give you zone descriptions, give you voice announcements for alarms, let you know system status, that sort of thing. So that's one of the features that you won't see on an Easy 8, but the M1 Gold does have those voice features. This system have a built-in astronomical clock so that it knows when sunrise and sunset occur based on your latitude and longitude or a city that you select, and that allows the system to know when it's light or dark outside, which can be useful when you're writing automation rules and that sort of thing. Our systems are flash updatable so that you can update firmware in the field to keep the hardware current, so that you can have a panel that maybe you purchased a few years ago working and operating at the same firmware and with the same features as a panel coming out of our factory today. The M1, with its automation capability, we use whenever and then logic statements, or what we call rules, and that's a very powerful part of the M1 system, and you're going to see some of that in action today as we go into this access control situation, this applications that we're going to be talking about. And we're able to interface with a lot of different systems. So we can talk to lighting systems and thermostats and AV systems, and we also have some partners that can help us with things like access control, and we'll also be going over a little bit of that closer to the end of the presentation. We're going to tell you about one of our partners that has some really cool access tools. Now, as far as features and specs of the system that are really directly related to the access control type application, we can have 199 users. The system is configurable for either 4 or 6-digit codes, so the users could be one of those codes. It could be a proximity card or fob, that type of credential. It could be a PIN number that you're entering on an access keypad. So 199 of those total, and you can have a mix and match of what those different things could be. The system can be partitioned into up to 8 areas. So that allows you to have different areas, and you can assign users to those areas. So you have some users that are allowed to go in certain doors and others that are not, and the partitions are how you would achieve that. We're able to control 16 doors directly. Now, we can expand on that quite a bit with a partner, again, that we're going to talk about at the end of the presentation, but as far as the M1 system and the hardware that is available for that system from ELK, we can handle 16 entry points. Our system supports 26-bit Wiegand devices, so if the device, whether it be a proximity card, a reader, or a access keypad, or maybe a combination reader keypad, if it has a 26-bit Wiegand output, then we should be able to support it. That's what we're looking for as an input to our keypads or access modules. Our event log holds 512 entries. And that event log can be viewed through our M1-to-Go software, which is an end-user application, and it's also available to some of the third-party systems that we work with as well. We can use the rules engine of the M1 that I was just talking about a moment ago to set up schedules and that sort of thing, and Brad's going to go into some detail on that as we get through the presentation here. So as far as access control applications are concerned, you can have that in commercial and residential. Of course, it's, more prominent in commercial. That's where you typically see that, and it can be, allowing employees into a business. As I was stating earlier, you may have an area that you want to restrict. Maybe it's your engineering department, and only engineers are allowed in that area, for example. So you could have that partitioned off into another area and only allow certain people in that area. You can control gates, and that could be residential or commercial. And another thing to keep in mind for residential that you may not think about access control, but you can use it to have like temporary or guest type users that could be easily enabled and disabled by the owner of the system so that they can allow guests or other people who might need a temporary code into the property. So let's talk a little bit about how those 26-bit Wiegand devices can be interfaced to the M1. We have several keypads that can accept a reader. So you're looking at the M1KP, M1KPB, which is the same as the KP that you're seeing on the screen there, but with a blue display, our M1KP2 and our M1KP3. And those all have a connector on the back of the keypad that a harness hooks to that you then wire the reader or the keypad, access keypad to. We also have our access module, the M1KAM, and it has an input for the reader and a relay output for your locking mechanism. It has request to exit input and a few other outputs, and we'll go into more detail on that, but it's for a single door. So the readers will either have to be connected to one of these keypads or the access module. You cannot connect a reader or an access keypad directly to the M1. And when you're looking at all of these devices here that can accept a reader, each one is capable of accepting a single reader. So this is where we get our limit of 16. The M1 can accept 16 Type 1 devices, and that includes keypads, access modules, and remote power supplies. So that's where we get that number of 16 entry points or doors. That's not a restriction on the outputs of the system. As I stated earlier, you could have up to over 200 outputs on the system. So that 16 entry point limit is based on the number of keypads one M1 can support. So I want to dive in a little bit deeper into each keypad and talk about how you would actually connect a reader to it. So what we're seeing on the screen now is the back of an M1KP or an M1KPB. They would look identical. Again, the only difference between those is the color of the display. There is a J2 connector, and that allows you to connect a reader or access keypad. Again, we're looking at a 26-bit Wiegand device. We actually offer an internal reader. For this particular model of keypad, it has room for a reader to be actually mounted inside the keypad. That part number is the M1PR, and you see it on your screen there in the lower left. And you can see that middle picture there just beside of it, how that actually connects to that J2 connector and then sits in that hole in the circuit board to allow that to protrude and be accessible by holding the credential close to the grill on that side of the keypad. If you happen to want to use an external reader with this keypad, there is a harness available for that. That is the ELK W035A, and that connects to either the KP or the KPB keypad. So you can see that's a 5-pin harness that's going to plug in right there to that J2 connector. So of course it's going to be either or. You're going to have the internal or the external, but you cannot have both. So now we're looking at the back of an M1KP2. An M1KP3 keypad, while the housing is quite different from the KP2, the back of the keypad is going to look pretty much the same. So you're going to be looking in the same area on the circuit board and seeing the same labeling, even though those keypads are very different aesthetically speaking. So on this keypad, you'll notice it's a 2-pin connector. J2 is just for your data. So when you're using this particular type of keypad, you're going to be using power either from the data bus connection or from an external source. You're not going to have power right on the harness like you did with the other keypad, which is a little larger and has more room for that sort of thing. There's different wiring harness that you're going to need because it is a 2-pin connection, and that is the W039A, and that works with both the KP2 and the KP3. And as I stated before, power is either going to have to come from the data bus or a separate source in this case. If you do use a separate power source to power the reader, it is very important that you have the negative of that power source be common with the negative of the M1. It's not going to work if you don't do that. Okay, and so this is the access module that I was talking about that you can use instead of a keypad for connecting your reader. It handles a single door, so you can see it's got a relay output on board for your door strike or your mag lock. It can accept either a 26-bit Wiegand device, or this particular access module can also accept a Dallas I-button reader. You don't have that I-button option with the keypads, but you do have it with this device. If you happen to want to use I-button, this is an option for you. This device connects to the M1 data bus, so you're going to follow all the same wiring rules for the data bus that you would for any normal keypad. We have 2 inputs available on this device. Input 1 is a request to exit input, and so you need to have something connected to that. Even if you're not going to be using a request to exit device, you would need to have at least a resistor strapped across that, so the resistor would go between the request to exit and the negative beside of it. So definitely keep that in mind. You can't just leave that terminal open or your access module is not going to work correctly. The door input is a programmable zone off of the access module, and that's something important to note that I may have kind of skimmed over here. As far as like your output on this device and outputs that are available on these keypads that we're talking about, that's assigned an output number based on the address of the device, and so you'll see a table in the instructions for either the keypads or this access module that would tell you if it's this address, then it's going to be this output number. Like say if it's address 1, it's output 193, for example. That's really important with the M1KAM because you are going to be using this output for sure to control your locking mechanism in I'd say most all cases. With the keypad, you may be using the voltage output off the keypad to trigger a relay, or you may be using just a separate output off of the system. So there again, it just depends on what you're doing there. But with the CAM, address of the module is going to directly relate to the output of the module as well as the door input. Again, that is a programmable zone. The request to exit input, the M1 controller doesn't get information on that, but it does get information on the door input. There are some other outputs other than the relay output on this access module that provide status, letting you know if the door's held open, if the system is ready to arm, or if it's armed. And so those can be used for LED indicators or some other interfacing so that you know the status of those things. And they are not required to be used, and you don't have to strap those out if you're not going to use them. ELK does offer a Wiegand reader. That's an external device. We call that our Ultra Prox. The part number is 106055. It works with our cards and fobs that work with our internal reader as well. And this reader can be used with M1 panels. It can be used with other panels that use a 26-bit Wiegand output. So it's a good reader to be aware of in either case. It is a slimline reader with a waterproof housing. You know, the electronics are protected with epoxy so that you can, you know, put this outside and it's going to give you years of service. You can work with the inputs on it and configure those for the buzzer and the green LED if you want to have something above and beyond what the device is going to do on its own. There are wiring harnesses that you can, you know, with wires you can apply voltage and control the buzzer and the LED. But those things are going to work automatically without having those extra wires connected. What's going to happen there is you're going to have LED indication of a good card read with the green LED, and you're also going to get a tone from the reader when it accepts a card so that you get that audible and visual feedback that it recognized the credential, the card, or the fob. You can see from the wiring diagram here, and this is showing an example of going to like a KP with that larger harness, that we have power available there. So we're using the red and black for power, and the white and green are going to be for your data. Of course, there are a number of other manufacturers that make readers and access keypads, and we're just looking for that 26-bit Wiegand output. So just listed a few here. I know this is definitely not an inclusive list, but just to give you some idea of some manufacturers that do make products that have been used with our system. And again, this could be an access keypad where you're using pin numbers. It could be a reader. It could be a combination of the two. One thing that's very important to note, and we run into this you know, fairly often, cards and fobs need to be purchased from the same manufacturer as your reader. So you can't interchange those. Even though it's 26-bit Wiegand, that doesn't necessarily apply to the card. It's more related to the output of the device itself. So there's, you know, there's like a manufacturer's code, so to speak, that are built into those readers and the cards and fobs, and they kind of have to match. So you can't get, say, an Essex reader and an Elk card and expect them to work together. Vice versa, you know, you can't use someone else's cards with our readers. So that's very important and can definitely get you caught up in a job. If you've purchased the cards and fobs from a different manufacturer than the reader, you may not be able to get that to work. So that's just something to keep in mind so you can avoid any problems related to that. So, of course, the M1 provides a lot of output expansion. I've hit on that a couple of times. This is how we do it. We have two different pieces of hardware that we can use for output expansion. If you need just more relay outputs, say you're, you know, connecting your readers to keypads and you want to use these outputs to control your locking mechanism, we have an output expander that goes on the data bus. That is the M1X OVR. You have 8 relays available off of that. We also have the M1RB, which also has 8 relays on it, but it works a little bit differently and it can be used in 2 different ways. So whereas the M1XOVR actually connects to the M1 data bus, the M1RB connects to either the J16 connector on the main board, converting those voltage outputs to relays, or it can be used in conjunction with the M1XOVR to convert its voltage outputs to relays. So the M1XOVR has the 8 relays on board. It also has 8 voltage outputs, and if you add an M1RB with just a ribbon cable, a very simple connection, then you actually get 16 relays off of that one expansion board using both parts. Okay, so we're talking about, controlling locks, controlling access to, let certain people in, keep certain people out. Door strikes and mag locks are your most common locking mechanisms, and this is actually an example of wiring a door strike. And this relay again could be off of the main board, that could be output 3, it could be off of an RB, an M1X OVR, or a CAM. Alternately, you could have the voltage output off of a keypad controlling a standalone relay. So there's, the relay could be from a lot of different places, but you're using it to switch one leg of power, in this case the positive leg, to your locking mechanism. Now it's very important that you put a diode across the positive and negative at the lock to avoid voltage kickback. It's also very important to note that you do not want to try to power that locking mechanism from the M1 data bus. M1 is able to provide 1 amp of continuous current, and most locking mechanisms are going to either be using all of that or exceed what the M1 is able to provide. So you want to have a separate power source for your locks. So gates typically work a little bit differently, and I'm generalizing here just based on knowledge that we have of common things. Of course, every product can be a little bit different, so you want to definitely reference any documentation you have for the product that you're working with. But generally speaking, most gate operators are just going to be a contact closure, and so you can just use the relay to go into those optional device input terminals on your gate operator, and through your rules have it just be a momentary closure when you have a valid read. So that's quite a bit simpler to hook up when we're talking, again, generally speaking, about those gate operators. Okay, so you can learn your cards and fobs in a few different ways. One option is to do that through the keypad. Now that means that the reader or the access device has to be connected to the keypad that you're going to be doing this from. If the reader is connected to a different keypad, or if it's connected to an access module, you're not going to be able to go to just any keypad and do that. You have to either be at the keypad it's connected to, or in the case of the M1KAM, you will have to program through the ElkRP software, which is Brad is going to show us how that works here in just a bit. But just to give you an idea of the keypad menus that you would go through, it's really rather simple to learn one in. At the keypad, you're going to go into menu 6, which does require a valid user code, and that's going to either be a master user or installer code. You would then select the user that you wanted to learn it into with your up and down arrow keys. Once you've found the user that you want, you'll right arrow into it. You'll see whatever that code happens to be now. If it's the first time it's ever been learned in, it's just going to be a bunch of zeros. At that point, you're going to present the credential to the reader. If it happens to be an access keypad, then you're going to actually enter the desired PIN. And you're going to see a 12-digit code pop up on the keypad. That is how the M1 is storing that particular credential. So it's just a few button presses, and either entering your PIN or presenting the card or fob, you have the user learned in. So I want to take just a moment now to address a couple of questions, and then I'll be handing the presentation over to Brad, and he's going to show us some things in the ElkRP software and how all this kind of plays out in that programming space. So one question we had, does a garage door opener or gate opener count as a door? As far as an output being taken up off the system, it would take an output for each one of those things. But as far as the door count is concerned, and I think that was, again, just talking about that number 16 and where we come up with that, again, that's based on the number of keypads or type 1 devices that the system can support, which is 16, and so that's a combination of your keypads, access modules, or supervised power supplies. So that's where we come up with that number. Another question that we have here is related to facility IDs on cards and fobs, and again, I think this ties back in with the conversation, or the part that we were talking about where you can't really interchange those with manufacturers. So If you get a reader from ELK, whether it be the M1PR, the internal reader, or the 106055, the external reader, you're going to need to get cards and fobs from ELK to work with those. The M1PRC is our card and the M1PRF is our fob. You really can't just get another manufacturer's cards and fobs and work with our readers. And the same applies in the other direction. Say if you got a, HID reader and it's a 26-bit Wiegand output, it can certainly be tied into the M1, but you're going to have to get your cards and fobs from HID, and that is because they have a manufacturer's code built into them that kind of ties them to specific readers from that manufacturer. Now that differs a bit from what may be referred to as a site code, and Brad will go into that a little bit more as he's getting into the programming, but when you are looking at the credentials, say if it's an ELK card, you're going to see some numbers printed on it. A 3-digit would be what we would consider like a site code, and then the 5-digit is the card number, and those are used to learn in the credential through software. So hopefully that clears up the difference between, the manufacturer's code and that site code. But if you have more questions about that, just let us know. And at this point, I'm going to go ahead and turn the presentation over to Brad, and he's going to tell us a little bit more about programming in ElkRP and how that works.
All right, thank you, Amy. Certainly do appreciate that. All right, so now we're going to talk about the ElkRP2 programming to help utilize the access control capabilities of the M1 system. And while the M1 is not a full-blown access control system, it does have a lot of nice features of an access control system that you can utilize. So let's get started and take a look at, oops, sorry, went the wrong way. All right, so programming the cards or fobs or pins. So first thing we'd want to do in RP is on the left-hand side, right-click on users, and we're going to create a new user. Now a box will come up that'll ask you how many users that you want to create, starting at which user ID. And in the case of our example here, we're going to create one user, starting at user number 2. We click OK. The next box asks us, do we want to use custom values or do we want to copy from another user? So if it's a situation where most of them have the same credentials, then you can always copy to help from having to recreate that information, or use custom if each individual is different. So once we've clicked OK, we now have our new user established. And on this screen here, we can assign the user a name. In this case, we've assigned it access user. We want to check that this user has access credentials instead of a regular 4-digit code, and this pertains to cards, fobs, or iButtons. Or it could be the numeric entry on a 26-bit numeric keypad. So on the ELK cards, that's our ELK M1PRC, there's information printed on the card. Looking at the middle set of digits, that is our site code. And then after that is the card PIN number. You can manually enter those into ElkRP, and that would create that 12-digit code that Amy spoke about earlier. So if we were to swipe this card at a reader that's attached to a keypad, we would actually see that 12-digit code appear, or you can manually enter it into RP. And then from there, we want to select the area that the card is valid in. And then if we're doing access control, most likely the only thing that you'll need to check is the access user authorization here. Now if it's a manufacturer, a different manufacturer that doesn't actually print this information or provide this information for you, then the only way to learn in that particular card would be to have a compatible reader connected to a keypad. You could go ahead and go into ElkRP and create your users, assign them their name, check mark user has access credentials, assign them to their area, and check access, send that to the system, then take the card or the fob to the reader that's connected to the keypad, and following those steps earlier, going into menu 6, we can learn in each card by swiping it in front of the reader, then receive this information back into RP. So what are some things that we can do? We can set up multiple areas. The M1 does support up to 8 areas. The users can be assigned to multiple areas. This allows restricted access to certain areas, like if you have an engineering room or a tool cage or something only certain people have access into. So let's talk about the basic rule structure for access. So in RP, under Automation and Rules, first thing we want to do is click New Rule. Under our Whenever statement, that's our trigger event, we're going to scroll down until we see Security/Alarms. You hover over this, you'll see Access. You can select any keypad, or you can be very specific on which keypad the card can be swiped at. So in this case, we're going to select keypad number 1 and OK. The then statement allows us to perform an action. And in this case, we're going to turn on an output. We're going to turn output 193 on for 10 seconds. Output 193 would be the voltage output off of the keypad address number 1, which we can use to control a relay. And that relay can then control the electric strike or the maglock. It can switch the voltage to either one of those devices. So when our rule is finished, we have whenever access keypad number 1 is triggered, meaning whenever the card or the fob is swiped at the reader, then turn output 193 on for 10 seconds. That is global for anyone that has access checked, and if keypad number 1 is assigned to area 1, the card or fob would also have to be assigned to area 1. Some other features would include automatically locking and unlocking of door. In this example, we have our door automatically unlock at 7 a.m. Monday through Friday, and then the door is automatically locked at 8 p.m. every day. For a business or just wherever, maybe it is for a tool bin or something that you want unlocked at specific times. We could say whenever it's 7 a.m. This is a conditioning and statement. These are optional. And the days of the week are Monday through Friday. And the output is already in an off state. We're going to turn the output on. This will remain on until 8 p.m. in the evening, when our next rule will fire that then turns the output off. Now let's say, for instance, we want to be a little bit more restrictive in who has access to this area. So once again, we create our access rule. Whenever access on the keypad number 1 is triggered, we want to be specific. So we have our conditioning and statement, and last user was John Smith, user 2, then turn output 10 on for 10 seconds. So this method is restricting that particular user so that he has 24-hour access, while the others may not, depending on how you have your other rules configured. So we can restrict access by time and day. In this example, for the groundskeeper, he is restricted to accessing the equipment area on Monday, Wednesday, and Friday between the hours of 8 a.m. and 6 p.m. So whenever keypad 2 is accessed, whenever the card is swiped or the fob is swiped at keypad number 2, and the last user was the groundkeeper, the days of the week would either have to be Monday, Wednesday, or Friday. The time would have to be later than 8 a.m. yet earlier than 6 p.m. for this rule to fire. So that's going to restrict him to these 3 days of the week during this time frame, and then he can gain access into this particular area. Another useful feature of the M1 in the rules for access control is being able to enable and disable users. So in this application, during a particular time of the day, in this case, whenever the time is 8:15 p.m., we've disabled these particular users. We've disabled user 4, 5, 6, and 7. When their code is disabled, it no longer works on the keypad. Now, since it is disabled, at some time we would need to re-enable that. So whenever the time is 7 a.m. and the days of the week are Monday through Friday, we've enabled these users. So for the maintenance person, the groundskeeper, a delivery person, or the pool technician, they will only be able to get into this particular, their code will only work Monday through Friday from 7 a.m. to 8:15. So how do we put it all together? When working with multiple rules that control the same lock, we want to make sure that we do not have rules that conflict with each other. So earlier we had some rules that turned on the output. We also had some 24-hour rules. So whenever the time is 8 a.m., we unlock the door. We turn output 10 on. Whenever the time is 6 p.m., we turn the output off. And we also have a rule here that says whenever access main entry keypad 1 is triggered, then turn main front door output 10 on for 10 seconds. That third rule will actually override the 8 a.m. As we can see, the output fired at 8 a.m., the door unlocked, but maybe perhaps the person didn't realize the door was unlocked, so they walk up, they swipe their card or enter their code. It then turned output 10 on for 10 seconds, the output turned off. So the way we want to get around that is to say, is the output already in an on or off state? So in our scenario, or we can justify using later than or earlier than. So whenever 8 a.m., we turn the output on. Whenever the 6 p.m., we turn it off. But now, whenever we have somebody who walks up and swipes their card, we can use a conditioning and statement. Is the time earlier than 8 a.m.? If it is, then it'll turn the output on for 10 seconds. Or if the time is later than 6 p.m., it'll turn it on for 10 seconds. That way, the door remains unlocked during 8 a.m. to 6 p.m. So our rules don't conflict with each other. That was a quick overview of how to do some general access control. Like I said, you can set up schedules to automatically unlock doors. You can set up scenarios where we restrict people during certain times of the day. You can also disable users or enable users. You know, it can be, we use maintenance and things like that, but it could be a guest. You may have people coming over at some time, but you don't want them to have access all the time to a vacation home or something. So at some point you tell the system you want to enable that particular user. Now we could also set up a task that did that automatically. If you have one of the smartphone apps, you could activate the task remotely and it would cause the users to be enabled. So if they're going to the vacation home, you can enable their code so they can gain access into the premise. Now one of our, Amy, do we have any questions at this moment before I jump into Connect One?
So I think we may want to dive into a live session of RP closer to the end and just go over a few other rule examples based on some of the questions, but let's go ahead and go over the Connect One part. I think we'll have time for that at the end.
Okay, sure, absolutely. All right, so one of our partner manufacturers, integration partners, is called Connect One, and they have come up with a very nice system to enhance the M1 product line. Connect One is a complete web-hosted interactive interface that offers the convenience to view, control, and interact with all of your systems from one screen. So as we can see here, we can view and manage and control security, access control, video, your heating and air. It can monitor critical temperature. You can do it from multiple locations, and like I said, it's all on one screen. They have a universal browser and mobile capability. No port forwarding is required, no additional software to install or maintain. It's a great way to generate multiple streams of recurring revenue. It's customized account management. They offer some great tools. Once again, this is Connect One with their interface to the M1. They've very good people to work with. You can see some screenshots that for the system. They allow for automatically locking and unlocking doors. They can create schedules. They can enhance the M1's capability and go further than what the ElkRP rule engine can do. They also offer emergency lockdown for doors. You can view system activity with filtering options, in and out reports and so forth, add and delete users with options for batch control, whereas the M1 doesn't have the capability of batching a set of or a group of users together for to make it a little easier to do multiple users if they have different schedules. The Connect One scenario does have capability for that. And they allow for multiple user login for simultaneous viewing and control of the system. Like I said, they've done a very good job in creating a lot of nice management tools for the system, as well as enhancing the capabilities. What we have here is the way they access the M1 system is through the Access Expander. This is the Connect One Access Expander. The hardware provides enhancements for up to 10,000 users. Those can be cards, fobs, or what they call ScanPass. It's a mobile app to ScanPass. 1,000 different profiles, permissions, and triggering actions. They have a 250 time schedule. That's full 7 days start-stop time and holidays. 2,500 event buffer. Lockdown support. Their app will support the viewing of up to 5 cameras. And they also provide elevator control. The Connect One Access Expander also allows a pass-through feature that would allow you to connect either the Elk M1 X EP or other third-party devices up to the M1 system. And ScanPass is a mobile credential, allows you to unlock doors or disarm and disarm the system from your smartphone. It uses the Connect One app to read the barcode installed at the entry points. It supports up to 203 doors and up to 10,000 users on one M1 control. So why choose the M1 system? It's a more flexible system. It allows for, we offer the greatest technical support available. We help generate repeat business and future upgrades for your customers' need. This is whereas in some systems where you're buying a lot of equipment up front and spending a lot of money up front for features that you may not be needing, with the M1 system it can grow with your future expansions. We have systems design and integration partnerships that offers a tailored solution for your customer's need. And also, like I said, through Connect One and the M1 system, you can maximize profits through recurring revenue and so forth.
Okay, so at this point, and do you happen to have it open on your computer, or maybe I can just switch to where I have it open on mine, the ElkRP software. Bear with me just a second here. Want to just go over a few rule examples. One of the things that we want to look at, Brad, is something that you had kind of alluded to, and it just goes to show with rules that there are lots of different ways that you can do different things. So one thing that you had alluded to was possibly just checking the state of the output before you decided to unlock the door. Can you kind of show us that?
Okay, sure, absolutely. Well, let's set up a real quick scenario. So if we say that during a time occurrence, that at some point during the day, like whenever the time of day equals, okay, we'll say 6 a.m., we are going to then turn on a particular output to control an electric strike or a mag lock. I'm going to use output my garage door, for instance. We'll pick on garage door. So we're going to turn it on. Okay, and then at some point in time during the day, we would like to turn that output off. Okay, so time of day, and we'll pick on 8 p.m. Okay, and let's see. I want to turn that output, turn output 10 back off. Turn it off.
I think you had picked output 9 before.
Oh, did I?
Yeah.
Okay. Oh, and I see what I did. Okay. All right. I see what I did. All right. Let me do that over. Sorry about that. Let's see. We'll go back in and do our time occurrence. It doesn't matter what order the rules are in. Even though I've got the turn off first, it doesn't matter. So we can go back in and we can adjust that real quick. Okay. 6 a.m. Then turn output 10 on. Output 10, I'm going to turn it on. Okay. Now then, these two rules fire 24/7 or 7 days a week at these particular times. So if we did have an access rule, like let's say for instance, whenever access on main entry keypad 1, okay, we then turn output 10 on for a duration. Now I got output 1. Let me change that. Output 10, we're going to turn it on for a duration. Okay. Now, if somebody were to walk up to keypad 1 and present their card, it's going to turn output 10 on for 10 seconds. That's going to override my 6 a.m. rule because it's going to turn it off at that point. So here's what I'd want to do. I want to edit this rule now, and I'm going to say, okay, I'm sorry, I want to edit this rule and say, add a conditionally and statement. I want to check to make sure that the output is off. And I'll explain why. So let me select output 10. Okay. Now my rule's done. So whenever access, let's say for instance the individual did not realize that the door was already unlocked. They walk up, they present their card to the reader. The access rule fires. It says, okay, whenever access on keypad 1 is triggered, but now it says, and output 10 is off. Well, at 6 a.m., we turned it on. So this rule would not fire. The output's already on. He can already go through the door with no problem, and it doesn't turn the output off until 8 o'clock. So that's how we could use the conditioning and statement and check for the state of the output to make sure it's either on or off depending, and prevent it from getting overridden through another rule.
Thank you for that. Another thing that we would like to see is the task option so that someone could, turn a user on or off from, say, a smartphone app while they're away. Can you show us how that would work?
Sure. Let's go under automation and tasks. Under task, a task, think of a task as a macro, or it's a predefined set of rules. And under where we have task, this is where you simply name it. So I'm going to go to task 11, and I'm going to say user 5 enabled. The show option allows this to show up on the smartphone app under the Task tab. The voice description, I can assign a 6-word phrase that I could use if the M1 is connected to a landline. I can call into the system and access the task menu as well. But here, this is just given a name. So how do we use this? So for instance, I say, I'm going back to rules now. I'm going back under new rule, and I want to say whenever, look for automation task, and I have task 11, that's what it was, yep. User 5 enabled, okay. I now go to then, scroll down to disable users, and I can now pick user 5 and enable his code. So if this is a vacation home or a rental property, or maybe you just don't want everybody gaining access all the time, at some point I could disable the user, maybe at a certain time of the day, and it disables it every day at that time. Somebody calls and say, hey, I'd like to go visit the home or see the property. Okay, hold on, and I access it through my smartphone. I access the task and click on it. It now enables this particular user and his code so that they can gain access and disarm the system.
Thank you for that. You could have a separate task, say it could be, task 12 that disabled that user. So if you wanted to, be able to enable it remotely, that the person who was there is going to be there for an hour or 2 hours, or you've seen maybe via cameras through Connect One or whatever that they're gone, then you would be able to, have another task to turn that user back off. So, and that would work pretty much the same way as what Brad just showed us. So that can be very useful. Another thing that we are wanting to see here, Brad, you might have, like, say, the owner of the system that's going to be coming in, and that, first they need to get in the door, but they also need to turn the system off. How can we make that easier for them so they don't have to, like, go to the keypad and put in another code for disarming? How would that work?
Okay. All right. Let's try a new rule. Whenever, let's go back under security/alarms. We'll look for access. So whenever access, and this time it's any keypad, because never know which door the owner may be coming in. So whenever access and last user was the master, okay, click OK, and we'll say, we can also condition it with and the system is armed. So we'll look under security, is armed to any mode, and this will be area 1. All right, then we will automatically disarm the system, area 1, and we may to also then control an output to let him in that door. So we'll look for this main gate output 7, so we want to turn it on for a duration of maybe 5-10 seconds, enough time to let them through. And so now, whenever access any keypad, a particular user, in this case the master, the system was armed, so we disarm it for him, and then we turn the output on to let them in.
Great. Thank you for that.
You're welcome. And we've done a couple other webinars on rule writing. We've touched on access control in those as well. So there's additional information on our advanced rule writing webinars on access control. But there's a number of different scenarios that we could do. If you have one in particular you would like for us to explain a little more, you can always email us at techsupport@elkproducts.com. We'll be glad to give you an example, or you can give us a call. We'll walk you through how to set up an access control rule and so forth. So what other questions do we have at this time?
I think for questions that are related to access control, we've covered them. Now we do have a moment or two, so if you did have a question, now would be the time to get it into us. We can go over those for you, or as Brad stated, you can certainly send us an email, tech support at elkproducts.com or training at elkproducts.com. Either one will get you connected to somebody that can answer your questions. So if you do have those questions, now is the time to get them in as far as getting them answered through this webinar. So just looking at, like we were talking before about like the output and the zone and how that's assigned based on the address of the device. Can you kind of show us on the keypad screen where it kind of just lays that out for you and shows you real quick and easy what your output number is going to be, say if it's a cam, or what
Okay.
your input will be?
Sure, absolutely. All right, so when we click on keypads, click on keypad number 1, for instance, and we have a note here. When you click on keypad, it's assigned to area 1. We also have a note that says if the zone is wired to the keypad, it's zone 193. This also applies to outputs. So depending on the address of the keypad, keypad number 2 would be zone and output 194. For a cam module, do we have one? Yes, we have a cam. It's set to keypad number 4. So we click on that. The zone and the output, for this case, keypad address 4 would be zone and output 196. And that's where we would use those in rules as far as turning those outputs on and off. The zone, if we were creating the zone for that particular device, that would be hardwired expander number 13. Click on 13, and then you can see where keypad 1, zone 193, all the way up to zone 208, which is on keypad 16, or it could be the cam module.
Great, thank you for that. Okay, it looks like at this particular time we don't have any further questions from the audience. We certainly do appreciate your spending time with us here today on this webinar. We hope that you've gotten a lot from it. If you do have questions after the webinar, definitely reach out to us. Email address is on the screen here, training@elkproducts.com. You can also, as Brad stated, get tech support at elkproducts.com. We'll get you connected with tech support.